if you can't get it, that's fine. I'm gonna, post the solutions this Friday after it's due. And then I'm thinking I'll either make a video kind of going over the homework, or I will go over it in class on Monday. And yeah, for the homework, you just submit the M file. So yeah, so I'll either make a video or I'll go over it on Monday, so we can, because I want to make sure that you guys understand the homework, and you can ask questions if you have any, because this homework, a lot of the coding techniques are going to be similar to the project, where we're using a lot of looping. So for the homework, we used cell arrays a lot, and I personally use that on the project. You don't have to use a cell array on the project, but in my opinion, it can kind of keep all your data a lot more organized. So, in a cell array, we can have, a ton of individual arrays in there. So we don't need to clutter up the workspace or anything. We can have everything in one kind of localized spot. But using cell arrays with for loops, I know that can get kind of confusing at times. So that's why I'll go over the homework, and then you don't have to use cell arrays again for the project. I'd personally recommend it, but you don't have to. But you, of course, do have to do looping, and all of the loops that you have to use there in the handout that we went over last time. And I think I mentioned it last time, but I'm not 100% sure, but I'm not going to show you the figures that we have for the project this time, because, that I guess the motivation behind it is that you guys should know what the figure should look like now, like with the formatting and everything. So I want you to kind of work to that yourself this time. Although technically you could actually, try to look up the figure online yourself. I'm sure that they are there somewhere, but you would have to do that yourself. Okay, so today we're going to go over a random number generation in the beginning, and then we're going to go over Simulink. So I think I sent out, that email last night for downloading Simulink. So if you didn't download Simulink yet, that's okay. You still have some time. So to do that, you'll go on the home page or the home tab in Matlab here, and then you can go to add-ons, and then you're just gonna search for Simulink. Okay, and then this should pop up. Of course, I already have it installed, but if you click on it and you didn't install it yet, you should see somewhere right here where you can install it. So if you can't get it installed today, that's, okay too. Obviously, it's best if you can get it installed so we can go over it, but if you can't, you can just kind of follow along just by watching today. But I know some of you in the beginning of the semester, you kind of wanted, or you asked if we were going to go over Simulink at least. So I decided that we'll go over it since we've covered a lot of the other important topics for this class, and Simulink is pretty important too. You're going to use it for, probably your vibrations class, maybe dynamics, maybe even some other classes, or for your senior design project, whenever you get to that, you might use Simulink for that too. And especially for the lab 476A, I mean, that's really just a Simulink lab itself. So if you can kind of already get a head start on Simulink to kind of understand how it works, that's, going to be good for you. Or if you're doing stuff like making your own quadcopter or something, you can even write your own code for that to kind of do some control system tuning, which is actually also a lab for 476A. So anyways, yeah, there's a lot of potential applications for using Simulink, so it's good to know. But we're going to go over that, later today. So we're first going to go over random number generation, then we'll do Simulink, and then you have your quiz. So your quiz, that's going to be one question starting at 11 a.m. And make sure that you copy and paste your code into the text box. Make sure you do that before the quiz is due. I know that seems like to always be an issue. and it's hard to extend the time on canvas. It seems like it just never works out. So just make sure you just copy and paste the code before the quiz ends. Even if you didn't, fully finish, you get a lot of partial credit. So just make sure you can do that. Okay, so we'll get started on random number generation. So we've already gone over this, a few times in class. Okay, question. How do I double check if you have Simulink? You can check, you can either just type in Simulink in the command window, or you can click on Simulink here. And if this window opens up, then you have it. If you don't have, or if that window doesn't show up, it might even show a dialog box to download Simulink. Or you can go to add-ons on the home tab, click on add-ons, and then search for Simulink. And if you have it, it's going to show that it's installed. If you don't have it, it's going to, show that you can install it. So just make sure you're installing this top one right here. Yeah, so this one here is something different. So just make sure you're doing this top one right here that has this figure. Okay, so random number generation. So yeah, we've kind of, gone over on the fly before, just for some of the examples that we've done in class. It was just convenient to use some random number generation, but this time we'll actually go over it specifically. So, so far for this class, it was just convenient to use random numbers sometimes, but depending on your application, you might actually want or need to use some random numbers for some simulation that you're running. So there actually is, a practical application as well. So we're going to go over uniformly distributed random numbers and then a normally distributed random number set. So the first one, uniformly distributed numbers, all of the values that we have in some range, they're going to be equally likely to occur. So if we have a range from 0 to 1, and we just have just one number, any number within that range is going to be equally likely to occur once we run this code. So if we use our function rand, this is just going to generate a random number that's uniformly distributed over the interval from 0 to 1. So if we just type in rand, that's only going to give us a scalar right now. So I'll go in the command window and I'll clear this. And if I type in rand, then we just get a scalar. So we only have one number. And, in my case, I get 0.81472. So if you type in rand in your command window, of course, you're going to get something different. So if I keep typing in rand, it's different each time. And of course, that makes sense because we're doing a random number. And how this actually works kind of behind the scenes is it gets a state from your CPU clock. So, that's not, of course, very relevant for your understanding. You don't really need to know that, but in case you were curious, that's what it does. Okay, so that's what we get right now. If we just type in rand, it's going from an interval from 0 to 1, and we get a scalar. Okay, so what we've done a lot in the class, though, is we've used rand to make an array. So we can do that, of course. So let's go into our script here. Okay. Make a section. Okay, so if we do rand n, meaning that's the syntax, that's going to give us an n by n matrix. So let's do a equals rand 5, and that'll give us a 5 by 5 random matrix for the range of 0 to 1. So each entry that we have in our matrix should be a random number within the range of 0 to 1. So if we run this, And we save our script first. Do random class. Okay, and then if we look at A in the command window, under matrix A, we see that we have a 5x5 matrix here, and then all of the entries that we have are, of course, a random number from the range of 0 to 1. Okay, so that works. We can also make a matrix that's, specific, that's not a square matrix, so if we want an n by n matrix, we can do that as well. So let's say I want to have a random matrix that is 2 rows and 4 columns. I'll just do rand and then 2 and 4. And I can run that. And then we have a 2x4 random matrix right here. Okay, so pretty basic so far. Okay, so a lot of the time what we did in class before was using the function randy. So rand, and then we have an I on the end. And this will give us a random number that's an integer. So instead of having something like 0.34039 like this first entry here, we'd get it a whole number. Okay, so we can do that as well. So the basic syntax for randy is randy and then imax. So imax, that's the maximum integer that we can have, and so that's going to go from 1 to imax. So it's a bit different than the function rand that we've been using. That's from a range of 0 to 1, but randy goes from a range of 1 to whatever number you specify. Okay, so let's do, I don't know, C equals randy, and then we'll put in 10. So this will give us a random whole number from 1 to 10. So if we run that, in this case, we got a 1. If we keep running it, okay, we got a 2, and now we got a 10. So if I keep running it, it's going to be different each time. Okay, and then again, we can specify the actual array size. So to do that, if we do, I don't know, let's do D, actually we'll do C. C equals randy, and then if I do 5, 2, our first argument in randy, that's going to be our imax size. So that's the maximum integer that we can have. So in this case, that'll be a maximum integer of 5. And then our second argument, which is 2, that's going to be the size of the array that we have. So in this case, it's going to be a 2x2 matrix. Sorry, my left ear's bothering me. Okay. So if we run this code, so we see that we have a 2x2 matrix here, and then our entries, we have random integers from the range of 1 to 5. So if I keep running this, they're going to be, different each time. Okay. So now I can also kind of extend this idea to have an n by n matrix. So for that, we just add on, just another number. So let's do a new entry. We'll do D equals randy. And this time, if I do 5, 2, 4, the first argument, that's going to be the range that we have. So that'll be a range from 1 to 5. The second argument, that's going to be the amount of rows that we have for our array. In this case, we have 2 rows. And then the last argument 4, that's going to be the amount of columns that we have. So in this case, that'll be 4 columns.
So what slides are these?
This is the odds and ends slides.
Okay.
Yeah, it's in the beginning. So right now I'm on slide number 7. Okay, so if we run this, let's unsuppress it. Then we get a random matrix that's 2x4 with each entry having a random number on the range of 1 to 5. So that's what we do for that. In this case, how this looks right here on line 13, it can be a little hard to kind of, or maybe not hard, but it's a little less clear on what we're doing. So You can rewrite this if you want. So we'll do E equals Randy. We'll do 5. That's our range from 1 to 5. And then we can do a comma, and we'll do in brackets 2 comma 4. So we're not actually changing anything here, but we're just making the readability a bit better. So, once we see these brackets here, we can kind of think in our head, okay, yeah, that's going to be matrix. That's 2 by 4. And if we run that, then we get a 2 by 4 matrix. If we don't specify the columns, it'll give us whatever column it wants. Now, if you don't specify the columns, you're going to get just a square matrix. So that's like on row 12 here. We didn't specify the columns explicitly. We just had a 5. That was our range. And then we put a comma 2. So if we only have this argument and we didn't specify the columns, that's going to give us just a 2 by 2 matrix. Okay. All right, so we can also specify the range of numbers that we want. So far, like on line 14, our range was 1 to 5 because we were using that kind of syntax there. But, maybe we don't want to start out at 1 for the range. We want to start out at some other number. Then we can do that too. So in this case, if we start out, or if we want to range from 2 to 10, we can do that. And then we can have, whatever size matrix that we want as well. So I can do F equals Randy. And then this time I'm going to use in brackets 2 comma 10. Now I believe that, yeah, I even had a note here. So at the bottom here, I said the arguments for the range. So we're doing 2 to 10 right now. They have to be wrapped in brackets. If you don't have these wrapped in brackets, then it's not going to work. So we'll do 2 comma 10. But for the size of the array, I don't have to wrap that in brackets. So right now I'm going to do comma 4 comma 2. So what this line of code will do is give us a matrix that has each entry is going to be within a range from 2 to 10. And it's going to be a 4 by 2 matrix. So we have 4 rows and 2 columns. So if I run that, then that's what we see. So we have a 4 by 2 matrix here. Then each entry that we have is within the range of 2 to 10. So of course, we can put whatever we want. If we want like 5 to 10, then that works too. We got all 7s there. All right. Guess that's what we can do. And then again, for readability, if you want, actually, before we do that, let's take out that bracket, these brackets. So let's make sure. And so, yeah, in this case, we get a multi-dimensional array, which we didn't really want. So if I want a range of 5 to 10, let's make sure that we do in brackets 5 comma 10. And then there we go. So we only have this one array that we wanted, which was a 4 by 2 matrix. And then again, for readability, which, I'm personally all about, of course, we can have our brackets there for a range of 5 to 10, and then we can use brackets again just to kind of, again, help with the readability to show that, okay, I want to have a 4 by 2 matrix, or, I don't know, let's do 20 by 10. I don't know why. And there we go. So now we have a 20 by 10 matrix with random numbers from the range of 5 to 10. Okay. All right, so now we're on random permutations of integers. So for this will make sure that we don't have any repeating numbers. So you see in this big matrix here, I have random numbers, but in a lot of these entries, we see that some integer shows up a lot of times. So we have like the number 10 that shows up a lot throughout here. So if we wanted to have some kind of random number generation with some array, and we don't want those, we don't want any numbers to repeat, we can do that as well. So for that, we're going to use the rand perm function. So do rand perm. Okay, so the basic syntax is going to be rand perm n. So let's do a equals rand perm. We'll do a 5 for now. And for this will just give us a row vector this time. So it's going to give us a row vector for the range of 1 to 5. And each entry that we have is going to be a unique integer. So if we run that, then we see that we have 1 to 5. So in this case, we only have 5 entries in here. So we're going to see, each number for the range of 1 to 5. If we're going to have 1, 2, 3, 4, and 5. So if we do, I don't know, rand perm of 10, that's going to give us 10 integers for that range of 1 to 10. So we're going to see each number for 1 to 10 as well. Okay, and we can extend this again for rand perm n comma k. In this case, we're going to have a range for n, so that'll be our first argument, and then we're going to have k unique integers. So for this, we need to note, of course, that k has to be less than or equal to n, or else it's not going to work out for us. So we'll do b equals rand perm, and so we'll have a range of 1 to 10, so that'll be our possibility for integers. And then for k, we'll say we want to have, I don't know, 3 unique numbers. So if we run that, then here we have, a factor that's 3, that has a length of 3. That was our last argument. And for that, we have a possibility to have a number from the range from 1 to 10. So in this case, we had unique numbers of 6, 8, and 10. If we keep running that, then of course we see that each time we have unique numbers. Okay, so normally distributed random numbers. I know I'm going kind of fast here, but I want to get to Simulink later on. So normally distributed numbers. Guess I should have said random. Okay, so for this, you can kind of visualize it as this normal distribution. That's the goal that we're going to have. Okay, so so far we've been doing a uniformly distributed random number. So if we have some range, then each value within that range is equally likely to occur. But if we want a normally distributed random number set, we can use the function rand n. So the n, of course, stands for a normal distribution. So let's do a equals rand n. We'll do 5. And this will give us a normally distributed random number set that's a 5 by 5 matrix. So we run that, then we get this this normally distributed set, and then I think the range is from -5 to 5 for a normally distributed set. Don't quote me on that, but I'm pretty sure it might be -4 to 4. Okay, so that's just kind of the convention now. Is there a function similar to rand perm for non-integers? Probably, but I can't think of it off the top of my head. But if you go to like Matlab on their website and you're looking at the documentation for rand perm, then at the very bottom of the page it'll show some similar pages that you can look at, and a non-integer function for rand perm that might show up too. Well, really, I guess that would just be rand, because that's gonna... Actually, I guess technically you could have a repeating number for that. It would be unlikely, but yeah, you can just look at the documentation. There might be a function for that as well. I would imagine there is. Okay, so if we did rand n 5, that's going to give us a 5 by 5 matrix. But if we want to specify the size to be not a square, we can do that as well. So we'll do rand n, And then, of course, this time, instead of putting just one number, we're going to put in 2. So if we want a 2 by 5 matrix, we can do that. And we have our normally distributed random number set for a matrix that is 2 by 5. Okay. So now we'll kind of visualize this to make sure that we actually are getting a random number set or a normally distributed random number set. So just by looking at our numbers, it's kind of hard to visualize if this actually is a normally distributed random number set. So we can make a plot to make sure that it is. Of course, it will be because they've written the code and verified it themselves, but we can look at this as well. So if I do a equals rand 10 comma 1, that'll give us 10 numbers, and then we have 1, so that'll give us a vector. So it's going to be a 10 by 1 vector. So if we run this, then we get all of our numbers here in the command window. And if we want to verify that that is a normally distributed random number set, we can make a histogram. So that'll show us the amount of times that each number shows up. So I'll do hist a, and if I run this, then we get our histogram that pops up here. Of course, this doesn't really look like a normally distributed random number set, but in this case, we have such a small sample size that it's not going to look great. So if we keep running this, then we'll see sometimes it actually does look like it is a normally distributed set, but really we need to increase our sample size here to something much larger, so then we can see that this function does indeed make a normally distributed random number set. So we'll increase it to like 1000. And then if we run that and we look at our distribution here, then this does look like it's a normally distributed curve. Of course, since it's random, it's not going to be a perfect normal distribution here. And if we increase it, I don't know, to 10,000, then you see it looks a bit better. So that's just some simple verification for this random number generation. Okay, so I think that's it. Yeah, that's it for the random numbers. Yep, yeah, a bell curve. So that's it for the random numbers. It's just for our application throughout the class, it was just convenient sometimes to use some random numbers, so we didn't have to make a 50 by 50 matrix by hand or something like that. We could just have Matlab do it for us on one line of code. But for some applications, you do need to verify some simulation that you're working on with random numbers. Like think of some random population or something. You can do that. Okay, so that's random numbers. So now we're gonna go over Simulink, and then you'll just have your quiz. So to use Simulink, all you have to do is let me clear this. So you can either type in the command window Simulink, or you can go up top here and click on Simulink as well. So if you click on that, and this window should show up here. It might take a little bit to open up because it's if you haven't opened up Simulink yet, it's kind of a big program itself. But once you do that, this should come up. So again, you can either click on Simulink up top here, or you can type in Simulink in the command window. Okay. And let me open up my slides as well. So these slides are on Canvas as well if you want to look at them. Okay, so we have Simulink ready to go. So we're going to click on Create Model, just a blank model here. And I should first, I guess I should provide some background for when you would use Simulink. I already talked about it a bit earlier, but The main thing for Simulink, at least that'll be most relevant for us throughout, school, is using Simulink. Here, hold on, I need to fix this. There we go. So you can use Simulink to basically turn up my mic. Okay, so you can use Simulink to basically model differential equations. Sorry, I was turning up my headphones. So you can use Simulink to model differential equations. So instead of solving a differential equation by hand, which I don't know if I think a lot of you will have taken that already if you've taken linear algebra, at least here, because that's a combined class. So yeah, you can use Simulink to graphically solve for a differential equation. So instead of solving it analytically by hand, which can take some time depending on the problem, you can model it inside of Simulink, and you don't really need to think too much. So that can be pretty convenient for us. And then of course we can make some graphs to kind of analyze whatever model we have for our differential equation. So a practical kind of example for this is if we have some dynamic system that we want to look at, we can make our free body diagram, and then we can then derive our equation of motion or our differential equation, and then we can model that inside of Simulink, and we can look at whatever results that we want to look at, like acceleration, velocity, and position, and then we can easily solve it that way instead of doing it by hand. So one thing we might do, I'm not totally sure yet, we might do it next week, is actually modeling a differential equation inside of Simulink and kind of going through that process. So of course we're not going to solve it by hand, but what you can do is solve it by hand yourself, and then you can make that plot, that analytic plot, and you can compare it to what you have in Simulink, and you'll see that they're virtually identical. Of course, Matlab has a numeric inaccuracy, but it's very, very negligible. But just because it's a computed answer, it's an approximation, so it's not going to be an exact solution like you would have if you solved it analytically. But anyways, that's the big area where we can use Simulink for. But there's so many things that you can do with Simulink. You can do circuits, some aerodynamic applications. I don't know, probably something with robotics. There's a lot of stuff you can do in Simulink. Okay, so this is what it looks like. So we already talked about how to open it. And so the library browser here up top, this is going to be where we have all of our blocks. So they're called blocks. So if we click on a library browser, this should pop up. So again, we just click on a library browser over here, and this will pop up. So you'll see on the left-hand side that we have a few things here. So we're just going to stick inside of Simulink here. And we have different, sections here. So we have commonly used blocks. So we're going to use a lot of these blocks, well, a lot of the time. And then you see that we have a continuous section. So this is like a PID controller, which you'll do in one lab for 476A. And then we have some functions for integrating. So you'd use that for your differential equations. And then you also have a derivative function, which we'll use sometimes as well. And let's see, another one that you might use is some math operations here. So we have a sine wave, which we'll be going over today. And I don't know, dividing, dot product, all of that kind of stuff. And then, also a gain block. So we're going to use gain blocks quite a lot to multiply. And let's see, we'll go to sources. So you can have a clock. So that'll just, set your time. You can use a ramp function, a constant, a step function. And this is actually when we would use the sine wave right there. So there's quite a lot of blocks. So you can access the blocks this way by going to the library browser and then selecting whatever you want. Or personally, what I do is I just left click on this canvas here, and then you can type whatever block you want to look at. So if we want a sine wave, I just left click and then I type in sine, and then I see that sine wave is right here. So we want a sine wave. Then you can press enter, and then your sine wave is going to show up. Okay, so that's two different methods to get our blocks into our kind of, I'm going to call it our canvas so I don't confuse it with the workspace inside of Matlab. Okay, so what we're going to do today is just model two sine waves. So something really, really simple inside of Simulink, and then we're going to export a time series from Simulink into Matlab, and then we're going to plot it. Okay, so first thing we have to do is get our sine wave. So we can either go in our library browser, and we can go to, what was it, sources? Yep. So we can go to the library browser, then go to sources, and then you can left click and drag sine wave. So you can do that, or you can just go on the canvas, left click, type in sine wave, and then press enter. So either method, up to you. Okay, so I'll zoom in here. Okay, so this is one sine wave. Now, of course, we're going to, or we can modify this. So if I double click on this block, then the properties for the sine wave are going to show up. So I can change the amplitude, I can change the frequency, and I can change the phase. The phase. So that'll be the most common things that we change here. So for this sine wave, I'm going to keep everything as the default value. So the amplitude is 1, the frequency is 1, and the phase is 0. Okay, so we want to have two sine waves. So to get another block here, I can either import a new block by typing in sine wave, or I can left click, Control C, Control V to copy and paste. And there we go, there's another sine wave. Or I can right click and drag on this block, and that's going to copy and paste as well. So I'll do that, and then we're going to modify this other sine wave here. So we'll double click on it, and for this I'll change the amplitude to, I don't know, to 2. Actually, no, I'll keep it as 1. I'll change the frequency to 3. Okay, so, I mean, it doesn't really matter. You can try something else if you want. But for me, I have the amplitude as 1, the frequency as 3. Okay, and then I'll click apply, and then OK. Alright, so any questions so far on Simulink? Okay. So what I'll do is I'm going to left click, and then you'll see that this little, I guess, label shows up. So I can double click on that, or I can just click on it, and then I can edit that name. So I'm going to call this sine of x. And then because I changed this frequency to 2, or did I make it 3? Yeah, I made it 3. So since I changed that frequency to 3, I'll change this to sine of 3x. Okay, and that'll just kind of make things, more readable again, so I know which block corresponds to which. Okay, so if I want to look at the output for these sine waves, I can use a scope. So I should also say, of course, what we're doing right now, we could actually just write code for that in Matlab. And, for this application, it would be easier to write code in Matlab. But if we're doing, instead of, modeling the sine waves, if we were solving a differential equation, then it's probably easier to use Simulink because we can just solve for it graphically using these blocks. So, this is a very basic example we're doing now, but it's just to show you what we can do in general. So if I want to look at the sine waves, actually visualize them, I can use a scope block. So I'm going to left click, and then I'll type in scope. If you're getting it from the library browser, it's going to be under Simulink and then sinks. So I'll type in scope. And scope is just going to allow us to visualize what the block looks like after we run a simulation. So currently we only have one port here to look at our scope. So if I connect sine of x to the scope, and to do that, I just left clicked on this arrow here, and then I just left clicked and dragged until I could connect it to the scope block. It'll kind of automatically pin or connect. Okay, so at this point, if I click on a run, I thought it would give us a dialog to save it. I guess not. So let's save this. I'm going to go to save as, and we're going to call this class Simulink model. So one thing that you need to make sure you do is save your model as a different name than the script. Okay, so I usually just put model at the end, so I'm sure that it's a different name. So I'm going to save that. And another thing, and this will be by default, but your script and your model should be in the same file or the same folder. Okay, so we'll save that. How did I pull up the scope? I just left clicked on the canvas and I typed in scope. If you're getting it from the library browser, it's going to be under sinks. Okay, so if we go up top here and we click on run, you see right here it says stop time. Currently, our simulation is running for 10 seconds. Now, of course, we don't actually have to wait 10 seconds. It'll go through, it'll run the simulation for whatever step size it's currently doing, and it'll kind of run that or simulate it for 10 seconds. So if I now double click on the scope block, then this is going to pop up, and this is our sine wave. So we only have one sine wave connected to our scope block so far. But you'll see here on our x-axis, we're going from 0 to 10, because we are going from 0 to 10 seconds. And then we can see our amplitude on the left-hand side here. So we had an amplitude of 1, so we're going from -1 to 1. Okay, but we want to look at both blocks, right? Both sine waves. So to do that, we just need to click and drag this, and once we do that and we go close to the scope block, it'll automatically give us another port, and then we can just connect that. Okay, so now if we save it and we run it, and now we double click on the scope block, now we see that we have two sine waves here. So we have in yellow, you see it doesn't automatically give us a legend, but in yellow that's sine of x, and then in blue that's sine of 3x. So our amplitude was the same, but the frequency was 3. Okay, so you see that it looks pretty terrible, right? It's pretty jagged, so at least for sine of 3x. So we can fix that. So to do that, we're going to click on the modeling tab up top here. So click on modeling, and then you're going to click on model settings. Okay, and this will pop up here. And so right now we have a variable step size. So it's doing this automatically to determine what kind of step size it needs to plot. But it's pretty bad, right? It's pretty jagged. So we can either click on solver details here, and then we can change the maximum step size to 0.01. So, this probably is familiar. We've done this a lot of the time when we specified our own step size inside of Matlab in a script. Or if you don't want the step size to be set to auto for these other parts here, we can just do a fixed step size, which I typically do. So I'm going to make that 0.01. So to go through that again, if you didn't see it, we're going to click on the modeling tab up top, and we're going to click on model settings. Oh, I should also say, if you're on an older version of Matlab, like I think even 2019, it's a little different, at least to get to the model settings. But if you're on 2020, it's going to look like what I have. Okay, so we click on model settings, and then I'm going to change the solver selection. I'm going to do a fixed step size. and I'll make that 0.01. Okay, then I'm going to click apply and OK. And now if I go back to the simulation tab and I click on run, now if I double click on the scope block, now we have very smooth curves here, which of course that's what we want. So we just increased our step size, or we made our step size really, I guess, smaller so we could have more values. Okay, there we go. So pretty easy so far, but now what we want to do is export all of this data into Matlab. So for this, for both of these sine waves, we have the actual value on the y-axis, and then we have our corresponding, or really, I guess I should flip that around. We have our x value, then we have our dependent value for the y-axis. So we have all of that data. It's in here, but we want to export all of that into Matlab. So to do that, we're going to use a block that's called toWorkspace. So I'm going to left click and I'll type in toWorkspace. If you're using the library browser, it's under sinks. So I'll just type in toWork, press enter, and then we get our toWorkspace block. So I'm just going to put that right here. And what I have to do is I need a toWorkspace block for each sine wave. So I'm going to connect this to just this branch right here for sine of x. It doesn't matter where I connect it, as long as it's connected somewhere along this branch. So I could connect it right here, or I can connect it down here. It doesn't matter. I'm just going to connect it right there. And I'm going to double click on this block. And I'm going to change the variable name, which by default is called simout. I'm going to change this variable name to sine x. And you also see that this save format currently is a time series. So we're going to keep it as a time series, but you could also change it to a structure with time, a structure, or an array. So typically you'd probably either do an array or a time series. We're going to keep it at the default setting, which is a time series. So I'll click apply and OK. I'm going to right click and drag to copy and paste. And I'm going to connect this one to sine of 3x. Okay, and then I'm going to double click on the block and I'll rename this to sine 3x and click apply. Okay, so there we go. And now we just need to save this. And now if I click on run, here's what I'll first do. I'm going to clear everything and I'll make a new script. And you also see on the left hand side here that our model is in the same folder that we're currently in. So if I go back to Simulink and I click on run, then you see that this just popped up in our workspace in Matlab, this out. The actual, I guess, class for this is a simulation output. So we'll go over that in just a second. Okay, so we have, this was, it went from Simulink to Matlab because we had these toWorkspace blocks. So I'm going to maximize Matlab now. And if let's just go to our slides. If I double click on this variable called out, then this will pop up. So we can see here that we have sine of 3x and sine of x, which we exported. And we also have an array here calledtout. So we double click on tout. Because we used a manual fixed step size of 0.01, we see that this is an array from 0 to 10 with a step size of 0.01, 0 to 10 seconds. If I double click on sine of 3x, then I can see, because we exported this as a time series by default, we also have all of those values for time here in one column, And then we have the corresponding dependent y values for the sine wave. And same thing for sine of x. We have the time in the left-hand side, and then our corresponding y values in the other column. Okay, so that's pretty convenient, but now we're going to write a script to kind of do this for us automatically, because so far what we had to do is we actually had to go in Simulink and then press run ourselves to get this into the workspace. So if I go in the command window and I clear everything, then of course it's not in the workspace anymore. If I wanted it in Matlab, I would have to go into Simulink myself and click run, and then it'll pop up. But if we're, if we just open up a script and we want to do this automatically, well, we can't currently do that because we have to go into Simulink and click on run ourselves. So what I'll do is I'll make a script where we can write some code to simulate the model automatically. So we're kind of getting a little short on time, so we'll go through this. So I'll do Simulink example. I'll do clear and CLC. Okay, so again, we want to automatically simulate our model. So again, you see that our model is here on the left-hand side, so make sure that you see that there. It should be by default in the same folder where you're making your script. So let's actually first save this script here. Okay, I'm in this folder. Yeah, I was already there anyways. Okay, so I'm gonna save this as a. So if you don't see your Simulink file here, it's just because we're only looking at .m files. It is still in this folder here, but it's a .slx file for the Simulink model. So I'm gonna call this class Simulink Script. I'll press save, and then you see that showed up on the left-hand side. We have our model up top here, and then the script below. Okay, so let's make a comment. What we want to do is import and run our simulation. So for this is when we want to automatically import our simulation and run it. So I'm going to assign a variable for this. You can call it whatever you want, but I'm going to call it sim. So I'll do sim equals sim. Sim is our function. Okay, so I guess I'll actually change this to, I don't know, sine wave, whatever. So I'll do sine wave equals sim of our Simulink model name. So for me, that was class Simulink model.slx. Then I'll suppress that. So now if I run our script, then you see that it actually ran this in Simulink, kind of behind the scenes, and there it is in our workspace. And now if I want to plot this, we have a time series. So because we have a time series, all I have to do is say plot sine of 3x, or I can say plot sine of x. So I don't even need to specify the x data and the y data. Because it's a time series, Matlab knows what the x data is and what the y data is automatically. So I'll do figure. I'll specify the size that I want. So I'm going to use position. I'll do 0, 0, 700 for the width, 300 for the height, and then I'll do visible on, kind of keeping with some of the techniques that I would recommend you use for your project. And then we'll do plot, and to plot our stuff, let me make this smaller here. Okay, so if I want to plot sine of x, then all I have to do is type in plot. I have to use dot notation for this. So we use dot notation for tables, and we're also going to use dot notation for this as well. So I'm going to do plot sine wave dot sine x. Okay, and then I'll do a line width of 2. And then if I run this, and look at that, I have our plot here. So quickly, I'm going to do hold on, and then plot sine wave dot sine 3x. That's the other one we had. give that a line width of 2, and I'll do hold off, and I'll do a y label of sine waves. By default, that was just called data. Our x label is actually automatically there as time for seconds, and I'll put in a title, sine of x versus sine of 3x, and then I'll do a legend, sine of x, that's what we plotted first, and sine of 3x, and then I'll put this in the northeast, and then I'll do legend box off. I'll run this one more time. I typed something wrong somewhere. Oh, I did sine waves. Okay, run that again, and there we go. So here is our plot where we have sine of x and sine of 3x. I'll move that a bit. Okay, so that's what we would do. I know I went very fast at the end, but your quiz is going to start in a few minutes. So yeah, that's how we have to export from Simulink into Matlab, and then we can make our plots here. Okay, so maybe next time we might go over solving a differential equation with Simulink, because that's, a lot more useful than just making sine waves in Simulink. So we might do that. I think that's a good idea. It'll be relevant too for your classes. I mean, you can even use this if you're setting up your model correctly. You could use it to check your work for solving differential equations. Okay, so that's all we're going to do today. So your quiz starts in 3 minutes. You have 15 minutes to work on it. It's a simple question. It is simple this time. I thought last time the looping would be simple, but I know that was kind of difficult, I guess. So your quiz today is going to be on solving a linear system of equations, and you're going to have to use left-hand division. Okay, so again, you have 15 minutes, and please make sure you copy and paste your code in the text box on Canvas in time. It's hard to add time after that, so make sure you do that in time. So I'm going to go to the quiz right now, actually. Okay, so this is what it's going to look like. You're going to have to solve this system of equations. So you need to solve for x1, x2, x3, and x4. And you have to use left-hand division. And you're going to copy and paste your answer in this text box. So write your script in Matlab if you're solving it in there, and just copy and paste it in here. Okay. So I'm going to stay on the call. I'm going to mute my mic, and I'm going to take my webcam off too. But I'll be in here if you have any questions, right? So good luck on the quiz. Starts in 1 minute.